Hi friend, welcome to my channel. So today we are going to sketch the graph of polynomials, okay? The first polynomial is here, as you can see, negative 2 times x cubed plus 6 times x to the power 2 plus 2x minus 6. So this is the factor form of this polynomial. This is your an, negative 2, and these are 3 factors. Okay, let's see. To sketch the graph, you need to look at the long run behavior, y-intercept and x-intercepts. So let's look at the long run behavior. So as x goes to positive infinity, y goes to what? In this case, as you can see, your an equals negative 2, which is negative, right? And also, if you look at the degree of this polynomial is 3. So n equals 3, degree is 3, and it is odd. So if you have a polynomial with odd degree and your leading coefficient is negative, then the long run behavior, x goes to positive infinity, your y goes to negative infinity, and x goes to negative infinity, your y goes to positive infinity. So your graph n behavior would be like this. So your n behavior goes over here as x goes to positive infinity, and x goes to negative infinity, long run behavior, y goes to positive infinity, right? So here negative infinity, positive infinity. So your graph is like something like that, okay? So that's the long run behavior. So let's find the y-intercepts. You know, to find the y-intercept, you have to substitute x equals 0. So let's see, y equals negative 2 times 0 to the power 3 plus 6, 0 to the power 2 plus 2, 0, negative 6. So what's the value here? As you can see, it's this is 0, 0 and 0, right? 0, 0, 0, and the rest is negative 6. So your y-intercept coordinate is 0, negative 6. Okay, so let's look at the x-intercepts. You know, x-intercepts are zeros of this polynomial. What are the zeros? So to find the zeros, you have to look at the factors. The first factor is x plus 1. So you know, the factors are in the form of x minus k. So in this case, your 0 is x equals negative 1 in this case. So then this one, x minus 1. So x equals positive 1. Here x minus 3. So x equals 3. So these are the zeros. At x equals negative 1, your polynomial, the y value equals 0. At x equals 1, y value equals 0. At x equals 3, y value equals 0. Right? So these are the zeros or the x-intercepts of your polynomial. So now we have everything, but we have to look at the behavior at zeros, right? So let's look at this one. So to find the behavior of your zeros, you have to look at the power of these factors. So here you can see it's power 1. So that means this one is a simple 0, right? And look at the next factor here, the power is equals 1. So this one is also a simple 0. And the other one also, the power is 1. So this one also simple 0. You know, if it is a simple 0, your graph is like a straight line. Something like this, right? Okay, straight line at that point. No bounces off or any other things, right? So let's graph this polynomial. So I'm going to find the zeros. X equals negative 1. So over here, the other one is x equals 1, and the other one is x equals 3. So I know my graph is my n behavior is like this, and on this side my n behavior is here. I should see something this side, and in this side I will see this way, right? So then since these are simple zeros, so my graph goes over here. So at x equals t, it's a simple 0. It's like this, right? And then, so my graph at this side like this, and this is also a simple 0. As you can see, my graph goes over here, right? But I don't know where is the turning point, but I guess it's like this. So this is I'm sketching my graph, so that's mean this 0 is a simple 0, again straight line, and also our y-intercept is -6, right, at this point. So that means this line goes over here, right? Let's see, like this, okay? And I don't know about the turning point. So in this side, you know, the graph goes over here, so it should be like this, simple 0, right? So let's think about your graph turn like this and goes like this, and we don't know the turning point, and because the graph should go over here. So let's see, I don't know, this is a sketch, right? So at this point your graph goes like this. Simple 0 should go like this, because on this side y goes to -infinity as x goes to like this. So it's like go like this and go like that. Okay, so this is a sketch of this graph. So these are zeros, right? So this is the sketch of your polynomial, this one. Okay, so let's look at another example. So this one. So this is the polynomial y equals x squared x minus 3 to the power 3 x plus 1. So in here, what can you see? It's in the factor form, right? And then look at the degree of this polynomial. So here x to the power 2, x to the power 3, x. So then n equals what? X to the power 2, x to the power 3, and x, right? So if you look at the powers, so this gives you x to the power 2, 3, 1, 6, right? So the degree of this polynomial is 6. N equals 6, which is even, right? And how about an? An is 1. So it is positive, right? Okay. If your degree is even and an is positive, your n behavior is like this. As x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y goes to positive infinity. So your graph should be like this. The n behavior like this, right? It goes to positive infinity. And let's look at the y-intercept. Substitute y equals 0 and find the, we have to find the y. You substitute 0 for the polynomial. 0 minus 3, 0 plus 1. So this is 0, this is 27, and this is 1, right? Then what's the value here? Is 27 times, so this is power 3, right? So this is negative, but since this one is 0, everything is 0, right? Okay, so you have 1, and because of this one, so everything is 0, right? Okay, so then 0, 0 is your y-intercept. And what are the x-intercepts? Look at the factors. So here x squared is x minus 0 squared, right? X squared. And you have x minus 3 to the power 3, x plus 1 to the power 1, right? So at x equals 0, you have a 0, right? At x equals 3, another 0. At x equals -1, you have a 0. So this 0, if you look at the power, it's bound, so it's 2, right? Double 0. This is double 0. So at x equals 3, you will see a bounce like this or this, right? So this is x equals 3. At x equals 3, power is 3. So this is 000. So your graph is flattened at that point like this, okay? Or it can be like this, okay? At x equals -1, the power is 1, so this is a simple 0. Okay, now let's graph this. At x equals -1, you have a simple 0. At x equals 3, you have a 000. And at x equals 0, you have a double 0. And y-intercept is also 0, 0, 0. Y-intercept 0, 0. And so end behavior is like this and like this, right? So as you can see, at x equals, you have a 000. So your graph comes from here, and it should be flattened at that point and then go down, right? And I don't know how far I should go, but I go like this, and at this point, at x equals 000, should be, so I'm over here, I should come to this point, right? It should be a bounce of x-axis, so 000 at x equals 0, right? So this one, and then at x equals -1, it's a simple 0. It should go like this. So my graph is over here, and it comes down, and it should turn like this and go like this, because end behavior is like this. So, but I don't know where this turning points, so this is a sketch of this graph. So if you want to find the exact turning points over here and here, you can graph this polynomial using a software, so you will see it, okay? So this is how you sketch the polynomial of the given polynomial like this, okay? So look at the y-intercept, long run behavior, x-intercept, and you can sketch this polynomial. I hope you understand this one. If you have any questions, please comment. Thank you so much for watching this video. If you want to see more videos like this, please subscribe to my channel. Bye.